This next part on box of the notes on box plots are going to review the 5-number summary terminology from the first part of the notes, and we're going to move on to drawing our actual first box plot. So the 5-number summary is simply the collection of all the information that we learned about last in the first video. So it consists of the minimum, the first quartile, the median or second quartile, third quartile, and the maximum. So we have here some data values from 2 forensic science technicians. We looked at these at the beginning of the last notes to look at what their range of the values were. So we have 11 samples from 2 technicians, and what we want to do is determine the 5-number summary for each technician. We'll also, just to review and practice, give the range and the IQR or interquartile range for each technician. So what I'd like you to do is pause the video, remember how to calculate those different values, and then resume the video in a second to check your answer. So for the first technician, the minimum value is 4, the maximum value is 10. We find the median for next, it's 7. Looking at the bottom half of the data, we find the first quartile value is 5 minutes, and then the third quartile value is 8 minutes. The range is the difference between the maximum and minimum value. The technician A has a range of 6 minutes, and the interquartile range is the difference between the third quartile and the first quartile. So technician A has an interquartile range of 3 minutes. Okay, again, if you haven't done it already, pause the video and calculate the same values for technician B now, and then resume the video to check your answers. Technician B has a minimum value of 1 minute, a maximum value of 13 minutes, giving them a range of 12 minutes. They have a median value of 7 minutes, a Q1 value of 3 minutes, and a Q3 value of 10 minutes. This means their interquartile range value is 7 minutes. Excellent. Now that we know how to calculate the 5-number summary for any data set, we're ready to begin drawing our box plots. So a box plot is simply a visual representation of the 5-numbered summary. We see a box going from the Q1 value to the Q3 value with a line signifying the median value in the middle. And then we see whiskers going from the box to the minimum value and going from the right-hand side of the box to the maximum value. Okay, it's fairly straightforward to draw our box plot, and for our first example, we're actually going to do a double box plot on the same graph, summarizing that information that we just calculated for the forensic technician A and forensic technician B. We've got the 5-number summary copied over here with the minimum, Q1, Q2, Q3, and maximum values for each of our technicians. So we're ready to draw our box plot. We've got graphing paper here. The first thing that we do is we have to decide on a scale and label our axes for our box plot. We pay attention to the range of the data and think about what increments we should go up on. Because we have to go from 1 to 13, or it makes sense to probably go from at least 0 to 15, we'll label every line with the digit 1. So the major lines will be 0, 5, 10, 15, 20. Our horizontal axis here is measuring the time for to conduct the analysis test. Remember, it's important to label with units, so that's the time in minutes being shown there. And so we're ready to start our plot. So we'll put Tech A we'll work on Tech A first. So you'll remember the first thing we're going to do is draw our box showing our interquartile range. So our box is going to extend from the Q1 value to the Q3 value. So for Tech A, that's going to go from 5 to 8. Okay, we draw a line at the median value, which for this technician is at 7. We then draw whiskers going from the Q1 value to the minimum and from the Q3 value to the maximum. Our first box plot is done. We're ready to move on to Tech B. When we're drawing multiple box plots on the same set of axes, we leave a space between the graphs. So for Tech B, I pay attention to my Q1, my Q3 value, and the first thing I'm going to do is draw a box that goes from my Q3 value up to, from my Q1 value up to my Q3 value. Okay, I'm going to put a line in my box plot at my Q2 value, which in this case is 7. And then I draw whiskers from my Q1 value down to my minimum and from my Q3 value up to my maximum. Excellent. So we've drawn our first box plots and we're able to visualize that 5-number summary and compare the distributions. We can see that Tech B takes longer on average. We see the relative size difference between their tests, and we can also see a bit of the skewness between our graphs. So both of our graphs are just slightly right skewed. Let's do one more example before we're ready to head off and do our homework. Okay, so we said that not only does our box plot let us see those 5-number summaries, the spread of our data, but can also help us identify outliers. And so that's the next thing we want to introduce is how do we know if a data value is an outlier? And so there's a formula that we're going to introduce for that. And the formula revolves around the interquartile range. So depending on how large the interquartile range is, that determines what our lower range for our outliers are and our upper range. So the lowest possible value, non-outlier value that we'll consider is going to be found by going below the first quartile 1.5 times the interquartile range. The highest non-outlier value is going to be 1.5 times the interquartile range above Q3. Okay. If there are outliers, we're going to just extend the max and min whiskers, not to the absolute max or min in the data set, but just to the lowest or highest non-outlier values. Okay, these rules might seem a little bit weird spelled out like as they are, so let's follow this up with an example that'll hopefully help illustrate the point. So we have a data set given to us and it's been ordered to help us through the process. So the first thing we're going to do to draw our box plot is figure out our 5-number summary. So we're going to count the number of values we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and find our minimum value that's given is 175. Our maximum value is 341, and we'll find that median value, our Q2 value, because we have an odd number data set, is going to be given by the middle number in our data set. Now we will find our Q1 value, the median of the lower half of our data, and then our Q3 value is going to be the median of the upper half of our data set. Okay, now that we've done our initial 5-number summary, we can calculate the IQR for our data set. Remember, the interquartile range is found by taking our Q3 value and subtracting our Q1 value. So our interquartile range for this data set is 42. Now we can figure out the lower fence on our data set. The lower fence refers to the lowest non-outlier value, or the lower limit at which a value starts being considered an outlier. So the lower fence is found by starting at our Q1 value and subtracting from it 1.5 times our IQR value. So we take 250 and subtract 1.5 times 42. Plugging that into my calculator, it comes out to a value of 187. So my lower fence value is 187. Any numbers in my data set that are lower than 187 are outlier values. So 175 is an outlier. My upper fence value is found by starting at Q3 and moving up, adding 1.5 times my IQR value. So I'd start at 292 and I add 1.5 times 42 to that value. Plugging that into my calculator, that comes out to 355. So any values that are larger than 355 are high outliers. Looking back at the raw data, right, I see no high outliers. Perfect. So we're ready with that information. We're ready to draw our box plot now. The first thing we need to do is label our axes. We think about the range of data we have to go from. So we still have to, we're going to still put the 175 on our graph. It's just going to be marked as an outlier. So we have to go from 175 up to 340. So let's let's mark starting at 150, 200, 250, 300, 350. We don't know what this data is for, so we're not going to have to label the axes. Okay, so now we proceed as normal. The first thing we do is we draw our box going from the Q1 value to the Q3 value. That doesn't change. My Q1 value is 250, my Q3 value is 292, okay, and I put those in. The next thing that I do is I label my median value with a line in the middle of my box, extending from both sides. Okay, I'm ready to draw my whiskers. So here's where things are going to change a little bit. For my lower whisker, I'm not going to go all the way down to the minimum because my minimum is an outlier. I'm going to go to the lowest number that's not an outlier. So in this case, I'd be going down to 201. Okay, for my upper limit, I'm going to go again to my maximum value. In order to put the outlier on, I label the outlier with a little dot at the appropriate spot. And our box plot is complete. Okay, so now you know how to label a box plot, even if there's outliers, how to identify outliers. If you have any questions, talk to your instructor, send them an email, and attend their office hours. Take care, and we'll talk again soon. Bye.